Hello everyone, welcome to the chapter of linear algebra. We will discuss here basis, dimension and some questions and then practice questions. Basis is linearly independent spanning set. Plural for basis BASIS is BASES. We will write basis as plural. A subset S of vector space V is basis if it holds two conditions: linearly independence and spanning property. Standard basis of a coordinate vector space Rn or Cn. For simplicity, we consider two space n equals to 2. So this is x direction, unit distance from here, 1 0 is point here. Similarly here 0 1. So we can write Ex or E1 as 1 0, E2 or Ey as 0 1. So these can be denoted by E1 and E2 in this curly bracket or Ex, Ey in this curly bracket. And we can write in this way, these are the bases in 2 space. Similarly, in 3 space, E1, E2, E3 will be standard basis. Generally, in Rn, n space, standard basis we will consider as E1, E2 and En. Also, Rn over R, this vector space is known as Euclidean n space, and Cn over complex C, this is the field, will be known as unitary n space. In 2 space, let us check how E1, E2 formed a basis. By this calculation, these are the LC. All these scalars E1, E2 are 0. Therefore, vectors E1 and E2 are Li, linearly independent. Any other Li pair will be there. 2 1 and 3 1 also forms a basis. There are so many other Li pairs in this space, 2 space, they will form a basis of a vector space. In general, basis of a vector space is not unique, but number of vectors in each basis is same. Let us consider polynomial of degree n. So monomial basis will be 1x, x square, x to the power n. Written in increasing order or decreasing order. Let us consider a matrix of order m by n. For example, we are taking a matrix of order 2 by 2. So we can say E11 or E1. This is the 1 0 0 0. E12 or E2. That is 0 1 0 0. E21, E22. These are standard basis for this matrix 2 by 2. Similarly, we can write standard basis of matrices of any order. Dimension. The dimension is the cardinality of a basis of V over its base field. So we can say dimension of vector space is uniquely defined. Now, dimension of matrix m by n is m into n. Now some restrictions are there or some conditions are applied there, then what will be the direction? Dimension of m by n matrix, if sum of each row is 0, that means mn minus m. Dimension of a square symmetric matrices, dimension will be n plus 1 upon 2, because order we are considering this one. Dimension of square skew symmetric matrices, n minus 1 upon 2, because we are taking n by 2 matrix. There are so many other dimension formula for matrices. Some conditions will be there. We have taken few of them here. Now let us consider this problem. So W1, that is the subspace UVWX belongs to R4. These are the restrictions, some conditions, and W2 will be this one. These are some conditions, restrictions. Then we have to find dimension of W1, W2, W1 plus W2, and dimension W1 intersection W2. These are the options. We have to select correct option out of these options. If we want to obtain dimension of this subspace W, so we have some ways for calculating the dimension of subspace. First way, we consider whole the subspace as a vector space, then apply the rule. Also, second way is that we will consider these coefficient matrices of these restrictions and finding the rank, and then we apply this formula. Basically, dimension of subspace, dimension of vector space minus number of Li restrictions. Li restrictions we will obtain out of these restrictions. We will obtain the coefficient matrix and rank of that coefficient matrix. Let us see how can we obtain the coefficient matrix and rank. So this is our coefficient matrix. Let us take A equals to this one. Only applying row reduced echelon form calculation gives us rank of A is 2, because row reduced echelon form gives us 2 non-zero rows. Rank of this matrix A is 2. Therefore, applying this formula, dimension of subspace equals to dimension of vector space minus number of Li restrictions minus rank. So B will delete the rank from dimension of vector space R4. Now dimension of R4 minus 2, which is the rank. So dimension W1 is equals to 2. Dimension W1 is 2. So this option is not correct. First option is not correct. Let us take dimension of W2. Considering the coefficient matrix B equals to something. Let us consider B equals to this coefficient matrix of W2. Obtain a rank. Rank will be 3. Dimension of W2 is dimension of R4, that is 4, minus rank is 3. So dimension of W2 is 1. But given here dimension W2 is 2. So option 2 is not correct. Now let us see remaining options. So we will obtain dimension W1 intersection W2, and we will see, let us take C matrix equals to this coefficient matrix. Matrix C is the coefficient matrix of W1 intersection W2. After calculation, this is the simple calculation, we will obtain rank of coefficient matrix of W1 intersection W2 is 3. Rank is of C is 3. Therefore, dimension of W1 intersection W2 is 4. Dimension of R4 minus rank minus number of Li restrictions. So this will be rank. So dimension W1 intersection W2 is 1. Here it is given that dimension W1 intersection W2 equals to 3. So this option also not true. Let us check this option. We will apply the formula. This formula dimension W1 plus W2. This one is formula. We are calculating this dimension of this dimension or any of the other. We have obtained this dimension as 2, this one as 1, this one as 1. So dimension W1 plus W2 is 2. Therefore, option 3 is correct. All are 1, 2, 4 are incorrect. Option 3 is only correct option. Now, these are some practice questions. Question number 1, question number 2. Let V be the vector space of all 2x2 matrices over reals. Let us consider the subspaces W1 and W2 as given here. We have to obtain the dimension of W1 intersection W2, dimension of W1 plus W2. Answer will be 2 for this one, and dimension of W1 plus W2 equals to 4. This is another problem. W is this one. Find the dimension of subspace W. Simplification gives us dimension W2 is 2. One can solve easily. If facing problem, we discuss, and for further notifications you can subscribe. Thanks for watching.